Welcome to Intelligence Gateway. What are the different 5G network deployment models? There are primarily three different 5G network deployment models. Non-standalone (NSA) deployment. This deployment model uses 5G radio access technology combined with the existing 4G core network. In this model, 5G radio access technology is used to provide enhanced data rates, low latency, and other 5G benefits, while the existing 4G core network is used for control plane signaling and mobility management. Standalone (SA) deployment. In this model, both the 5G radio access technology and core network are built from scratch. This allows for the full implementation of 5G capabilities, including ultra-low latency, network slicing, and other advanced features. SA deployment is considered the ultimate goal of 5G deployment. What are the different 5G use cases? There are many different use cases for 5G technology, including enhanced mobile broadband. eMBB 5G can provide faster and more reliable data transfer rates for mobile devices, allowing for better streaming of high-quality videos, music, and other data-intensive applications. Ultra-reliable low-latency communication. URLLC 5G can support mission-critical applications that require low latency and high reliability, such as autonomous vehicles, industrial automation, and remote surgery. Massive Machine-Type Communications. MMTC 5G can enable the connectivity of a large number of devices in a network, such as smart cities, smart homes, and industrial IoT. What are the different 5G applications? Some of the different applications of 5G technology include autonomous vehicles. 5G can provide the low latency and high reliability necessary for autonomous vehicles to communicate with each other and with infrastructure. Virtual and augmented reality. 5G can support high-quality streaming of VR and AR content, allowing for more immersive experiences. Smart cities. 5G can enable a range of smart city applications, including traffic management, public safety, and environmental monitoring. Healthcare. 5G can support remote monitoring and telemedicine, as well as enable more advanced medical applications such as remote surgery. Energy. 5G can enable more efficient and reliable energy distribution and management, as well as support the integration of renewable energy sources. What are the different 5G services? Some of the different 5G services include enhanced mobile broadband, eMBB. This service provides faster and more reliable data transfer rates for mobile devices. Fixed wireless access, FWA. This service provides high-speed internet access to homes and businesses through 5G wireless connections. Ultra-reliable low-latency communication, URLLC. This service supports mission-critical applications that require low latency and high reliability, such as autonomous vehicles and industrial automation. What are the different 5G standards? There are several different 5G standards, including 3GPP Release 15. This standard defines the first phase of 5G and includes support for sub-6 GHz frequency bands. 3GPP Release 16. This standard includes support for higher frequency bands, as well as enhancements to existing 5G features. 3GPP Release 17. This standard is currently being developed and is expected to include further enhancements to 5G features and capabilities. What is the 5G New Radio (NR) standard? The 5G New Radio (NR) standard is a set of specifications developed by the 3GPP for 5G wireless communications. It defines the air interface between 5G devices and base stations, including modulation, coding, and frame structure. What is the 5G Core Network (5GC) standard? The 5G Core Network (5GC) standard is a network architecture that provides the core functionality of the 5G network. It is designed to support a range of new services and applications, including in turn Internet of Things (IoT) devices. What is the role of software-defined networking (SDN) in 5G technology? Software-defined networking (SDN) plays a key role in 5G technology by allowing for more flexible and dynamic network management. SDN enables network operators to programmatically control network functions and services, allowing for greater efficiency and scalability. What is the role of Network Functions Virtualization, NFV, in 5G technology? Network Functions Virtualization, NFV, is an important technology in 5G networks as it enables network operators to virtualize and deploy network functions on standard hardware. This allows for greater flexibility and scalability, as well as reduced costs and faster deployment times. What is the role of cloud computing in 5G technology? Cloud computing plays a key role in 5G technology by providing the infrastructure and resources needed to support the massive amounts of data generated by 5G networks. Cloud computing enables the deployment of virtualized network functions and services, as well as provides scalable and flexible computing resources for data processing and storage. What is the role of edge computing in 5G technology? Edge computing is a critical technology in 5G networks as it allows for the processing and storage of data closer to the end user or device. This reduces latency and improves the overall performance and efficiency of the network. Edge computing enables new applications and services, such as autonomous vehicles, smart cities, and industrial automation. What is the role of artificial intelligence, AI, in 5G technology? Artificial intelligence, AI, plays a key role in 5G technology by enabling network operators to optimize network performance, predict and prevent network failures, and automate network management tasks. AI also enables new applications and services, such as virtual assistants, autonomous vehicles, and smart cities. What is the role of machine learning, ML, in 5G technology? Machine learning, ML, is an important technology in 5G networks as it enables network operators to analyze and learn from massive amounts of network data. This allows for more accurate predictions and faster problem resolution, as well as improving the overall performance and reliability of the network. What is the role of big data analytics in 5G technology? Big data analytics is critical in 5G technology as it enables network operators to analyze and make sense of the massive amounts of data generated by 5G networks. Big data analytics allows network operators to identify trends, optimize network performance, and provide new services and applications. What is the role of cybersecurity in 5G technology? Cybersecurity is a critical consideration in 5G technology as the increased connectivity and use of new applications and services create new security risks. Network operators must ensure that 5G networks are secure and protected against cyber threats, such as hacking, data breaches, and malware. What are the security challenges of 5G technology? There are several security challenges associated with 5G technology, including increased attack surface. 5G networks are designed to connect a large number of devices and sensors, which increases the attack surface of the network. This means that there are more entry points for potential attackers to exploit. Virtualization. 5G networks rely heavily on network virtualization, which introduces new vulnerabilities that can be exploited by attackers. Virtualization allows for greater flexibility and scalability, but it also means that there are more potential points of attack. Edge computing. 5G networks rely on edge computing to process data close to the source, which reduces latency and improves performance. However, this also introduces new security risks as the edge devices may not have the same level of security as the core network. What are the privacy challenges of 5G technology? One of the major privacy challenges of 5G technology is the large amount of data that is generated and transmitted by the network. This data includes personal information such as location, browsing history, and other sensitive information, which can be intercepted by malicious actors. Additionally, the use of more connected devices and sensors in a 5G network can also increase the risk of data breaches and unauthorized access. To address these challenges, 5G technology providers must implement strong data encryption, access controls, and other security measures. What are the ethical challenges of 5G technology? The ethical challenges of 5G technology include issues related to privacy, security, and equity. As 5G networks enable the collection and transmission of vast amounts of data, there are concerns about the ethical use of this data and the potential for misuse by governments and corporations. Additionally, the deployment of 5G infrastructure may have environmental impacts and could disproportionately affect low-income communities. Ensuring that 5G technology is deployed ethically and equitably will require careful consideration of these issues. Thanks for watching. For more information, like, comment, and subscribe our channel.